Hello everybody, I am Hemant Singh Pokhariya. Hope you all are doing great. Today we will discuss synchronous sequential circuit. Okay, and before that, I would like to tell you what is the basic difference between combinational circuit and sequential circuit. In combinational circuit, output depends upon only in present inputs, not in past outputs. But in sequential circuit, output depends upon present inputs as well as past outputs. Means there is memory element. For this, we will provide a feedback path from output to input. This is your feedback path. Okay, and in sequential circuit, again it is further categorized into two types: a synchronous sequential circuit and synchronous sequential circuit. In asynchronous sequential circuit, output may change at any instant of time when input changes. But in synchronous sequential circuit, this is your synchronous sequential circuit, we apply a common clock pulse to all the flip flops, and in this output changes only when there is either positive edge, this is your positive edge, or there is negative edge. So we can say that in synchronous sequential circuit, output changes in a discrete interval time, but in asynchronous sequential circuit, output may change at any instant of time when input changes. Okay, this is your asynchronous sequential circuit and this is your synchronous sequential circuit. Now we will see latch or flip flop. This is your latch, this is your SR based latch. What is latch or flip flop? It is the smallest unit of memory which is used to store one bit information at a time. What is register? Register is group of flip flops. What is counter? It is again group of flip flops. So this topic is very important for upcoming topics. Without this, you cannot be able to understand counter, register and synchronous sequential circuit and asynchronous sequential circuit, because it is the basic component of any sequential circuit. Okay, this is your SR based latch. In there are two inputs S and R and two outputs Q and Q bar. In this there is a cross coupled connection between input and output. Output of this is connected to input of this. Similarly, output of this is connected to input of this. Now we will see what possible combination can be there. Now this Q, okay, this is flip flop output, or you can say latch output. Flip flop is nothing. When we will apply a clock pulse, it becomes simply flip flop. When we apply a clock pulse in latch, it will become flip flop. Now there are total two input and there is one Q. This is nothing your present state. So there are total 8 combinations. There are total 8 combinations. Okay, this is SR and this is Q0. Q0 is present state. What is Q? It is next state. It is next state. It will work as a pass value for this. Now with the help of S, R and Q0, we will determine the value of next state Q and Q dash. Okay. Now you know the basic property of NOR gate. What is the basic property of NOR gate? If any one input is high, output will become 0 irrespective of other value of inputs. So by using this concept we will determine value of q and q dash. Now there are two possible value 0, okay, and next value of q0 is possible 1. First we will determine the value of this 0 0, okay. So this value is 0, this value is 0, this q0, this is 0 passed output. Now you know 0 and 0, what will be value? This will be 1, okay. You know the property of NOR gate. Now this 1 and this 1, you know 1 and plus 1, 1 and this will be, because there is bubble, so it will be 0. This is 0 and what will be value of q bar? It will be 1. So this will be 0, this will be 1. 0 0, this will be 0, this will be 1. So we will write down 0 here and 1 here, okay. 0 1. From here you can see q, this next stage equal to present state, so q is equal to q0. Now we will determine value for 0 0 and 1, 0 0 1. Similarly you can determine now 0, suppose this is 1 1 1 and NOR of 0, it will be 0 and 0 0 it will be 1. So it will be 1 and it will be 0 1 0. So q again q equal to q0 means there is no change, means memory is retained. You can say in this case it remembers last value. Now next possible combination can be SR 0 1 and value of q0 equal to 0. This is your 0 1 and this is 0. Similarly you can find out this. Now this is 0 0 plus 0 and not, it will be 1 1 and 1, it will be 0. So this value is 0 and q dash will be 1, okay. And from here we will determine value of q in terms of q0. Now value of q is possible value can be 0, it can be 1, it can be q0, okay. Similarly for next value 0 1 1, 0 1 1. Similarly determine this value 1 0, okay, it will be 1 0 0 0 1, again it will be what? 0 1 0. So you can see this is 0, this is complement 1, just write down 0. From s equal to 0 r equal to 1, in both cases value of q and value of q are 0 0. From here we can say q is 0. Now one important thing, in flip-flop you have to remember there are two output, always there are two output, q and q dash, and the must condition is that both output will be complement of each other. If it is 0 it will be 1, if it is 1 it will be 0. Both cannot be same. Suppose this is 0, it cannot be 0. Suppose it is 1, it cannot be 1. If such type of condition come, in that case there will be invalid condition. We will see when s equal to 1, r equal to 1, okay. And from these two you can directly apply shortcut method, okay. You do not need every time to determine this. This is 0 1, this is 0, this is 1. Now you know the property of what? NOR gate. If any input is high, output will be low irrespective of value of other inputs. So if this is 1, it is 0, so from here determine this. If any one input is high, it will be low, so it is 0. Now from 0 0 you can determine value of output of this case 0 0 1. So directly you can write down 0 1 in both case. Next, now for 1 0, this is your 1 0. Okay, in 1 0 suppose value of q is 0 0. Similarly determine this and this output. Now I will apply shortcut method. Okay, I will apply shortcut method. S equal to 1, R equal to 0. First determine this. If S equal to 1, irrespective of this value, you can determine the value of this. If this is 1, okay, this is 1. If any one input of NOR gate is high, other value can be 0 or 1. You know output will be 0. Okay, it will be 0. It will be 0. Okay, and 0 0. You know 0 0. It will be 0 0. It will be 1. So directly you can write down 1 0. So this value will be 1 0. Similarly for next case, apply shortcut method. Now S equal to 1, R equal to 0. Okay, this value will be 1. In both case, if q0 equal to 0, again value is 1. If it is 1, again value is 1. So from these two we can conclude next state q equal to always equal to 1. This condition is called set flip flop. This condition is called set. When flip flop becomes set, if output of flip flop is 1, and you have to remember uncomplimented output of flip flop is 1 and q bar equal to 0, this condition is called set. And if q equal to 0 and q bar equal to 1, this condition is called reset condition. Q equal to 0 means reset condition. If value same, there is no change. Now last possible value can be 1 1. Now if 1 1, now directly you can apply shortcut method. If any one input is high, output of NOR gate will be always equal to 0. Okay, so you can see in both cases you are getting same output 0 0. This is not possible. Okay, this is must condition is both output will be complement of each other. So you are getting 0 0 0 0. Similarly here again for 1 1, similarly you are getting 0 0. This is 1 1. So this is the table how you will determine value of flip flop output with the help of flip flop input and past output. Okay, and now I will summarize this. If shortcut table, this is called the characteristics table. Okay, shortcut, if value is 0 0, output will be same. So next state will be present state. So this is q0. It is called no change, means memory is retained. When S equal to 0, R equal to 1, you have to remember S means set, R means reset. If it is 0, it is 1. In this case, value of Q will be 0. This is called reset. If 1 0, it is 1. If S equal to 1, R equal to 0, this is called condition is called 1. This is set. If both are same, if both are high, in that case there is invalid condition. Okay, because you are getting same output. You know what is the complement of Q? It must be Q dash, and it is not possible to have same value in Q or Q dash. Okay, this is your SR latch. Similarly for NAND base, this is your NOR based latch. Similarly for NAND based latch, you can determine the characteristics table. This is your NAND based latch. In this case, again apply the shortcut method. You know what is the dual of NOR? It is NAND. And in NOR, in case of NOR gate, if any one input is high, output will be low irrespective of other inputs. So you know the duality theorem, change 0 by 1 and 1 by 0. So how you can say in NAND gate, if any one input is low, output will be high. Use this concept. Okay, suppose both are 0 0. If any one input is low, in case of NOR gate, output will be high. Okay, first 0 0. I will just apply shortcut method. If you are getting this type of condition, if any one input is low, if it is 0, it is 0. You don't need to bother about this Q and Q bar. Okay, if it is 0, it is 0. What will be output of this? It will be 1. And what will be output of this? It will be 1. So both output cannot be same. So this is called invalid condition. Okay, or you can say it is forbidden condition, or you can say indeterminate condition. In this case, we are getting when S or R equal to 0. Okay, and similarly find out for S equal to 0, R equal to 1. S equal to 0, R equal to 1. Now this is 0, this is 1. Without noting the value of Q, Q0, you can directly write down next step. Suppose this is 0 and this is 1. Okay, now first determine output of this. If it is 0, then one input is low, output of NAND gate will be, this is 0, it will be 1. Okay, 1 and 1 and 1, it will be 0. Okay, 1 0. So in case of, if it is 0 and it is 1, if any one input is low, output will be what? High. You will get 1 and this 0. So 0 1 1, and value of Q is 1, value of Q dash will be 0. Similarly in this case 1 0, output of this Q will be 0 and Q dash will be 1. And in case of 1 1, okay, there will be no change. You will get the same output. So you have to remember, you can apply shortcut method only when any input is low. For this, you will first consider value of Q, first 0, then next time 1. 1 1, value of Q 0, and you will get the same output, Q 0. Okay, 1 1 0, you will get 0. 1 1 1, you will get 1. So no change. Okay, this is all about your latch. And when we apply a clock pulse in latch, it becomes flip-flop. And you know what is the function of flip-flop. It is the smallest unit of memory and it is used to store one bit at a time. You can see from latch here, it is used to store one bit, either 0 or 1. Okay, and in case of latch and flip-flop, you have to remember there are two outputs. One is Q, next is Q dash, and both must be complement of each other. If not, that will be invalid condition. Next, if S equal to, S is set condition, R is reset condition. Okay, and in next class we will see different types of flip-flops. Okay, there are different types of flip-flop: SR flip-flop, set reset flip-flop, next JK flip-flop, D flip-flop, and T flip-flop. It's all about today's lecture. Thank you so much for watching. Have a nice day.